Alright, so this video is going to be part 3 of our absolute and conditional convergence practice. Okay, so we want to prove if the series is absolutely convergent or conditionally convergent. And we have our series, the sum from n equals 1 to infinity of negative 1 to the n over natural log of n plus 1. Alright, so the first thing we want to do is see if this series is going to be convergent or divergent, okay? If that's something that we can prove. Well, since this looks like a alternating series, all right, we have that negative 1 to the n over natural log of n plus 1. So that natural log of n plus 1, that'll stay positive, all right, but this negative 1 to the n is going to make this an alternating series, okay? It's going to alternate between negative and positive, okay? So the first thing that we should probably check for, we should use the test for divergence, okay? And you'll see more about the method of going through all the tests and stuff. That'll be in a little bit after we learn the last two tests. Okay, so the limit as n approaches infinity of negative 1 to the n over natural log of n plus 1. Well, this negative 1 to the n really won't matter at all, but you can see that as n approaches infinity, this n right here, that's going to become infinitely large, right? And this is going to be natural log of a really large number, which is going to be a very, very large number, which makes this limit go to 0. Okay, that proves absolutely nothing. So we need to move on to the alternating series test. Now, for the alternating series test, we need to see if our b sub n, okay, which we'll figure out here in a second, is going to be decreasing, and if the limit as n approaches infinity of b sub n equals 0. Okay, how do we get that b sub n again? Well, we're just going to remove what is making this series alternating, all right? We are going to remove this negative 1 to the n. We're left with 1 over the natural log of n plus 1. Now, is this a decreasing series? Well, it is, because if you go to the next term over, okay, this is n, right? If the next term in the series is going to be n plus 1, okay? So we can use n plus 1 to compare to. So this is natural log of n plus 1, okay? But now we're going to substitute in an n plus 1 for n. All right, watch what happens here. We have a 1 over natural log of, this is going to be n plus 1 plus 1. All right, and of course we know that's going to be natural log of n plus 2, all right? And natural log of something bigger than this natural log of n plus 1 is going to be a bigger quantity. So since this denominator is bigger than this denominator, we know that this whole fraction is less than this fraction. So we know that this is greater than this, okay? So that means that it is decreasing. We can put a little check mark there. The last thing that we need to do is take the limit as n approaches infinity of that natural log. So we take the limit as n approaches infinity of 1 over natural log of n plus 1. And of course, as we kind of saw in the test for divergence, this limit is going to equal 0. Whether you have that negative 1 to the n there or not, it's going to equal 0. Okay? So we know that it is also, we know that the limit as n approaches infinity of b sub n is 0. Our conditions have been met, so that means that this is convergent by the alternating series test. Alright, now, we need to see if this is absolutely convergent or conditionally convergent by seeing if the absolute value of this series is going to converge or diverge. If it converges, then we have absolute convergence. If it diverges, well, then we have conditional convergence. So, this series, when we take the absolute value of it, we lose that negative 1 to the n, so we get 1 over natural log of n plus 1. Alright, basically our b sub n from before. Alright, same thing. So, how are we going to prove whether this is convergent or divergent? Okay, well, we can use some kind of comparison here. 1 over natural log of n plus 1. Well, we can compare that to 1 over n, right? Sort of similar. So we know that 1 over n, that's going to diverge, right? That's our harmonic series that diverges. So we'd like this to be greater than 1 over n. Now, let's try just plugging in 1 here. Okay, if we were to plug in 1, we get 1 over the natural log of 2, right? Well, natural log of 2, that's less than 1, okay? Which is what you get over here when you plug in 1. You just get 1. So this denominator is going to be greater than, or actually, sorry, less than this denominator right here. Because here you get something that is less than 1. Here you get something that is 1. So since this denominator is less than this denominator over here, the whole fraction is greater than the 1 over n that we have on this side here. So we can already say that this is going to be divergent by the comparison test, okay? And why can we say that? Well, we know that 1 over n, that's our harmonic series, okay? That's our harmonic series. We know that diverges, and if 1 over natural log of n plus 1 is greater than something that diverges, well, it's going to diverge as well. So it is divergent by the comparison test, and let's kind of review what we did here before we can say whether this is absolutely convergent or conditionally convergent. Our original series here, we figured out that that was convergent by the alternating series test, okay? So that means, of course, we at least know that it is convergent. Now, if we take the absolute value of that series and prove whether that is convergent or divergent, that tells us whether it's absolutely convergent or conditionally convergent. Now, since we found it to be divergent, well, that means that it is going to be conditionally convergent. Okay, and if you're wondering, well, why did we even need to do this step in the first place if we could have just taken the absolute value? Well, if this ends up diverging, well, this is just going to be divergent anyway. Okay, that'll just be divergent. There's no absolute convergence or conditionally convergent. No, it's just going to be divergent. Okay, so we need to make sure that is going to be either absolutely convergent or conditionally convergent and not divergent. Okay, that's the other option that you'll also see on some of probably your practice problems, stuff like that. So that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for absolute and conditional convergence, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.